Okay, so we have a motion problem here where a person starts out behind a vehicle and the vehicle's moving that way at 50 kilometers an hour. Now, in case you haven't thought about this in a little while, we've seen that you can keep track of the position of a moving object, and if you take the derivative of that position, you get the velocity of the moving object, because velocity is how fast is your position changing. And you can differentiate that and get the acceleration, because acceleration means how fast is your speed changing? How fast are you speeding up or slowing down? And now that we've got antiderivatives, we can go in the opposite direction. If you have acceleration, you can integrate that, find its antiderivative, and that will tell you the velocity. And if you have velocity, you can integrate that and get back up to position. So we can now get from any one of these values to any other one. We've kind of completed the loop because of what we've learned about antiderivatives. So in this case, they tell us our velocity is a fixed number. It's just 50. So if we want the position, if we want to know where we are, we can integrate that. Our position is the integral of the velocity, which is 50 dt. And so when you integrate that, you get 50t plus a constant, which I do not know. But can we find it? We could if we had one more piece of information, and they hand us one right here. They say, he was 10 meters behind the car at time 0. So when the time is exactly 0, the position was 0.01 kilometers. Did you catch what happened there? When you use a velocity in kilometers per hour, you're committing to, okay, from now on, all my distances shall be in kilometers, and all my times shall be in hours. 10 meters is not kilometers, so I had to divide this by 1,000 to get a value in kilometers. This we can use. We can use this to solve for c. We can do s equals 50t plus c. That's our position, 10 meters or 0.01 of a kilometer. This is our 0 hours because we're at time 0, and we want to see what constant comes out of that. The constant is 0.01, and so that means that our position function, all finished now, is 50t plus 0.01. That is good. We can get stuff with that. The actual question that we can finally answer is, how far is the sedan away after 6 minutes? So we have to put 6 minutes into here. And I am not, or I should not do this. Why not? Because our velocity was in kilometers per hour. All our times have to be in hours. 6 minutes is no good. I can't use it. So, quick side calculation. 6 minutes is 6/60ths of an hour is 0.1 hours. That's the time we have to use. And so that distance comes out to 50 times 0.1 is 5 plus 0.01 equals 5.01. And if this is a distance, it has to come out in kilometers because, again, when you choose those units, those are the units that you're putting in. Those are the units the math will give you back. Distance 501 kilometers. And if they ask for any other distances, we have this formula. It's all worked out. We know the c value even. We could answer any other questions they had.